Hey guys, welcome back to our TransCAD tutorial. I'm Danny. Today we are going to introduce trip distribution, the second step of the four-step approach. For this tutorial, we are going to use a workspace in the tutorial file. It's called distribution apply gravity. First, just to give you a little bit review of trip distribution. We apply a gravity model to calculate the number of trips going from node I to node J. And the formula here we have PI, which is the trip production by node I, and a fraction of them will go to node J. And that fraction is calculated by this, which is the attraction number of node J times a friction factor between node ij times a k factor between I and j. Down here is divided by the sum of the same terms looped over all the nodes for j. In our example, this k factor, we are going to ignore it. It's a socioeconomic factor. We are going to focus on the Fij here, the friction factor. So how to calculate this term? We have some options. The friction factor from node I to node J is dependent on the cost to travel from node I to node J, which is defined as Cij. And once you have that cost, then you can get the friction factor by either an exponential function or a gamma function or inverse function, or you can have a friction factor table to look up. So we're going to use these options later in the tutorial. So coming back to the tutorial, here I have opened this workspace and we have several input. So first of all, we have this friction factor table, and we can do a little trick to put things nicely for review. We do window and horizontally. We'll put things neat together. And in this friction factors table, we have the field of time, which is the travel time in minute. For example, if the travel time from a node to another node is 3 minutes, then if it's a home-based work trip, then the friction factor will be 0.3946. If you are looking for other trip types, then you can also find the number. And intuitively, the longer the travel time is, the smaller the friction factor would be. That means in our gravity model formula here, the less likely that trip will happen. So that's the friction factor input. This table, you need to prepare it if you want to apply it. And another input is what we have seen before, just geographic files, a map. Most important thing, in this TAZ layer here, if we open the table behind it, we can see for each zone, if we come to the right, we have this P and A, these trips. If you still remember from tutorial 2, these are the outputs of tutorial 2, the output of trip generation. So here what we have is the balanced trips of production, which is P here, and attraction, which is A here. We can do a quick compute statistics, and we can come here to see the sum. For home-based work trip, the P and A, they are the same. So this is balanced, and so it goes for the other trips. They're all balanced. So this is what we need as an input for trip distribution. And we can minimize it for now. Also, obviously, you have this layer of the streets, which are the black line, and also this highlighted highway in our map, and the endpoints, which contains a lot of centroid in our zones, as well as some junctions, which are not shown in here. The third input we have is this matrix table called shortest path. Here, the shortest is defined as the shortest free flow time path. This, if you still remember, this is an output from our tutorial 1. And if you are lazy, you don't want to check that out, then very luckily for you, I will pretend that we don't have this input, for example, and I will regenerate this shortest path matrix table for you. Alright, so now let's begin. Okay, here we have this map with a lot of zones with their centroids, just like here, what we see on the map. So now that we have the map and we have the trips ready, we have the friction factor ready, the only thing we need to do is to get the matrix of shortest path. And to do that, we will need first to get the network. To have that, you should switch the active layer to the streets layer. In our example, it's called base year network. And then you do network paths and create. And just to give you a review, what are the options here? So the inputs create from the entire line layer. That means all the streets, all the links, that's fine. And length field, because we will always calculate the shortest path after creating network. So TransCAD always needs something to minimize. And at least you should have the length for TransCAD to minimize. So that's why it always asks for the length field. In our example, we already have that field, which is called length. So it's already there. You can ignore these other options. Here, since we are going to calculate the shortest path based on travel time, so here we choose link fields, and we want to add the free flow time in there. So this free flow time field of the links will be included in the network file. And we click OK. I'm going to just name it this and overwrite my original file. And now the network file is created, and in the status bar we can see it. It's automatically the active network file. So with that, we can now go to get the shortest path matrix. We do network paths and multiple paths. Here we choose what to minimize. The only two options are the length and free flow time. We choose the time. And from to, what nodes? We should select centroids. These centroids are already selected for us in this tutorial file by the field called TAZ. I can open it for you. So here, in the subset, we can see the centroids are already selected. And for the data view of the endpoints, this field called TAZ, if we do sort decreasing, we can see some nodes have this TAZ value. That means they are a centroid of a zone. Otherwise, like these points, they are just intersections. This was also introduced in tutorial 1. You can review it if you forget about it. And come back to the calculation of the matrix of shortest paths. Here we select centroids, two centroids. And that's it. The results will be stored in the matrix file, which is exactly what we want. We click OK, and you can change the name of the output file if you want. Click OK, and it's finished. So this is our matrix table of shortest path. You can see all these numbers going from zone 2 to 1. The shortest path, it needs a free flow travel time of 6.09 minutes. And here we can see that on the diagonal line we have a missing value for all the OD pairs. That makes sense because in each zone everyone is represented by just a node. So if you are traveling within a zone, you are going from this node to this node. So your travel time will be 0 or missing. But in reality, the trips within each zone, it still has some travel time. And we can make a rough estimation of that. If we do not have the data, then we can make a rough estimation of that by planning and trip distribution and intrazonal travel times. So what it does here is that for each zone, it will get all these travel times to the other zones, and then it will pick the 3. If the number here is 3, then it will pick the 3 shortest travel time and get a scaled average of them. So you can choose different numbers here. I'll just use the default 3. And here operation to replace the original value of missing, that's fine. And we click OK. And now we have these numbers. So the trips within zone 1, the average free flow shortest path, it would need 4.26 minutes just to fill our diagonal line here. Alright, so now we have the third input ready. And let me make the nice view of the tables again. Let me bring this back to, so we will have 4 of them. This looks better. Yeah, and now we are ready to do trip distribution. So we go to planning, trip distribution, and gravity application. Here we will choose the tables and choose our options. So first of all, the production attraction data, where does that come from? That comes from our table called TAZ, which is the data view of the zones. And here we have this production and attraction fields. So that's fine. And then second, friction factor settings. The friction factor table, that comes from our friction factors. This table right here. And you can ignore this. Sorry, the impedance matrix, which means where does our cost come from. So that's this shortest path table. Okay, so that's the input tables. And now here we will set up the models we want to use in terms of, for each trip type, how do we want to calculate the friction factor given our cost? Do you want to use exponential or gamma or inverse, or do you want to just look up in the table? So for different types of the trips, we have to set them up one by one. So here, for purpose 1, that's the name of the trip. We can change it to home-based work trip when we hit enter. And the production and attraction, it picks up the name, so it finds that there's a home-based work trip production field there, so it automatically fill that in. And also attraction is HPWA. And iteration, you can specify how many iterations you want. And the convergence, this is the criteria for convergence. And method, here we choose what function we want to use. So let's say we do gamma for home-based work trip. And once you choose gamma, come back to our formula, you see we have three parameters called A, B, and C here. The same name convention in the TransCAD setting up here, A, B, and C. And by default, it gives us some value to use. You can change it if you need to. So I'll use the default value. So that's my setup for home-based work trip. And let's also do the others. We click this pencil to add trip, and here we add home-based non-work trip. And hit enter. It also got these two fields already. And for this one, let's say we use the exponential function. And once we choose that, we see A and B, we cannot change them. We can only set up number for parameter C. That's because we only have a C parameter in exponential function. Similarly, if you choose inverse function, then you will have only parameter B to change. Like this, all right? And we can also add another one for our non-home-based trips. And it got this P and A fields again. And for this one, let's use the table. The F factor, where does that come from in the table? That's we're looking at non-home-based trips, so we should choose non-home-based trips friction factor field. It already chose that for us. If not, you should make the selection. And since we're using the table, we don't have any parameters. And that's all the setup. And we can click OK. Here we can change the name. And here we have the calculation finished and the little report. Show us how convergence is going. You can click close and close this report. And here is our final results for the trip distribution. It's a matrix table giving us for each trip types. Let's say first home-based work trip. For each OD pair, how many trips there will be. You have all these numbers, and you can go to home-based non-work trip. All the numbers. You have non-home-based trips. Just to have a quick check, we can do the compute statistics again, just to see the sum. For home-based work trip, the sum is 545,000. Is that right? According to our original table, do a sum for that. And for home-based work trip, the sum is 545,000. So that's the correct calculation we confirm. So close these two tables. So this matrix table will be our final results for trip distribution. And this process is sometimes referred to PA to OD, which means PA, production attraction results, to OD matrix results. depending on your data, sometimes this matrix you get, the numbers here are the daily trip numbers. So you may want to convert this daily OD matrix to a time-dependent, like peak hour OD matrix. So that's another story and will not be covered by our tutorial here. So that's all for the tutorial today, and see you next time for model split. Thank you.